And do you see here how the law of sines isn't going to work? I mean, what could I write with the law of sines? I know what the law of sines says. It says the sine of alpha, for instance, over 37 is equal to the sine of beta over 45, right? Well, why doesn't that work? You don't know any of the angles, so you can't take the sines of things. You're going to have two unknowns if you try to use the law of sines. You guys understand? So to be able to use the law of sines, I really do need to have one of the angles. And sometimes you don't. And that's a situation where you're going to have the law of cosines need to be working. Okay. So anyways, what I'm going to do is I'm going to use the law of cosines in one of its forms, and I'm going to find one of the angles. Which angle do you want me to find first? Alpha. If I want to go for alpha, let's say that's the angle I want to go for, then I have to write the correct form of the law of sines. Law of cosines, I mean. This one has gamma in it. Okay? I'm going to need to use a different law of cosines formula. There are two more. One of them begins with b squared, one of them begins with a squared. Now Justin said, hey, go for alpha, so which one do you think I want? I want the one with the a, okay? Because your three different forms of the law of cosines, you're always going to have cosine of an angle, and that corresponds to the thing on the other side, okay? So Justin said, hey, let's go for alpha. So I know that if I'm going for alpha, that means over on here, I'm going to put a squared. Okay? So I'm going to write a squared equals. And then what am I going to write here? Well, I'm going to write the other two sides. What are they going to be? B squared plus c squared minus, what do you think I'm going to write next? 2bc cosine alpha. Okay? And I'm going to use this to find what alpha is. I could fill everything in. Let's see what I have. I have a squared, so I'll say 37 squared equals 45 squared plus 26 squared minus, and then I'm going to use parentheses here, 2 times 45 times 26 cosine alpha. Now you know what we have now? We have a trig equation. If I could solve a trig equation, I could figure out what the angle alpha is. Okay? Now some people would go right to the calculator now and start typing things in. I'm going to do a little algebra first. I think it's a little cleaner. I'm going to start out by bringing all the squared stuff to the left-hand side. So I have 37 squared minus 45 squared minus 26 squared is equal to negative 2 times 45 times 26 cosine alpha. Do you guys follow that? Okay, that's nice. Next, I'm going to divide both sides by what? Well, by a lot of stuff, right? Because what are you trying to get by itself? This cosine. Let me go a little slower, and let me just divide both sides by a negative 1. So I'm going to say, and let me just switch the sides too. 2 times 45 times 26 times cosine of alpha. If I divide by negative 1, that changes the signs of all these things, right? So it's going to be positive 45 squared plus 26 squared minus 37 squared. Does that make sense to people? I just divided by -1, so I changed all the signs. And I wrote the positives before the negatives. We usually do that. So now if I want a final answer, I can say, well, the cosine of alpha is equal to whatever 45 squared plus 26 squared minus 37 squared is, and then I'm going to divide by what? 2 times 45 times 26, right? I mean, that's what it is. I think at this point I'm ready for the calculator. Okay? So let's see if I can use the calculator to figure out what alpha is. All right, we'll try it. So punching that up, let's see. 45 squared. Let me clear this out. 45 squared plus 26 squared minus 37 squared. Okay? I'm going to press enter. If I didn't press enter, if I want to type the whole thing in, you got to keep the numerator in parentheses, and you also have to keep the denominator in parentheses. As a matter of fact, when I divide here, I'll type the whole denominator in at once, but I'll put it in parentheses. 2 times 45 times 26. So there you go. What is that? That's the cosine of alpha. Right? Now, am I in degree mode? Yes. I should make sure of that, because now, in order to figure out what alpha is, right, I know that the cosine of alpha is equal to, well, 0.5692. So alpha, let's see if we can get it. What does alpha equal? Well, we'll do the inverse cosine of 0.5692. And let's see what we get. 55 degrees. Okay? So there's 55 degrees. So I think as a good exercise, you know, that's alpha. I think I'd like you guys to find gamma for me, using the law of cosines that we first wrote down at the top of the page. Okay? I'd like you to work with someone on it. Find gamma. Do you think that gamma is going to be a larger angle or a smaller angle than alpha? Maybe. Why smaller? C is smaller. That's right. So we know that a smaller angle will be across from a smaller side. All right. Let's let you work on that for a couple minutes and make sure we can find. So if I go back. Yeah. I guess if I were going to be a little more precise, 55.3 degrees is what we got for alpha. But if you go through the same calculations, you guys can get gamma. And he says that gamma ends up being 35.3 degrees. Is anybody getting that? Okay. Hey, by the way, do you have to use law of cosines to find gamma here? Not anymore, right? Because I already got alpha. Hey, for example, once you know alpha and gamma, don't you have beta like for free now? Because what do you know? The angles all have to add up to what? 180. So if I already got gamma, let's say, I could do 180 minus, well, the sum of whatever this is. So if it's 55.3, and you guys said the other one is 35.3, then you could get it. So then 89.4 would be what beta is, right? See, once I have those two, I can get the third. So yeah, once we have those two, we can get that beta is 89.4. But I guess the question is, do you guys still need help getting gamma? How would I find gamma? Well, you guys are using law of cosines like I just did. What? Well, you guys found it, but I didn't show how to find it yet. Right? I guess you guys did it using this formula up here, the law of cosines with c squared first. Is that what you guys used? Okay. What I'm saying is there's a faster way, and that is you could have just said, well, I found alpha, so I actually know alpha in the picture we figured out is 55.3 degrees, and it's across from 37. So I could now use the law of sines to find one of the other ones, because I know sine of alpha over 37 is going to be the same as the sine of gamma, let's say, over 26. So if I want to find gamma, I could say the sine of 55.3 degrees over 37 is equal to, well, like I said, the sine of gamma over 26. So if I multiply both sides by 26, 26 times the sine of 55.3 over 37 will have to equal the sine of gamma. Right? I can see that these fractions are equal. Multiply both sides by 26, and I have a 26 up there. So here I have it now. I can say 26 times the sine of 55.3 degrees and divide by 37. There's a big mess. That equals the sine of gamma. So if I take the inverse sine of that answer, that's another way to get gamma. 35.3 degrees. Okay. Which is what you guys got using law of cosines, I think. I like the law of cosines, but it's a little bit longer than the law of sines. So I tend to use the law of cosines when I have to. I use the law of sines when I can't. You guys understand? So sometimes you use the law of cosines in another situation. You may be given an angle and a couple of sides, and sometimes you have to use the law of sines in that situation. So like here's a dumb problem, but I have to put it down. It's kind of funny. Problem 4 from your book. They tell me the following. They tell me angle A is 3. No, not angle. Side A is 3. Side B is 4. And they tell me angle gamma is 90 degrees. All right, so I'm going to draw a picture. Of course, angle gamma being 90 degrees means what kind of triangle do I have? I have a right triangle, right? This is a right triangle. That's gamma, right? And I have, well, 3 and 4, right? This is A, and this is B. So if you think about the parts of this triangle that I still want to determine, I'll put them in blue. We want to figure out C, that's the side opposite gamma, right? We want to find alpha, that's the angle opposite A equals 3, and we want to find beta, that's the angle opposite B equals 4. Now which one do you think I ought to find first? I think the C. What does C equal? Well, you know it equals 5. How do you know? 3, 4, 5 right triangle. Let's say you didn't know that. Okay? Suppose you don't know what C is. Is there another way you could find it? Well, there's a reason you can't use law of sines. Why can't I use law of sines to find C? Because if you wrote c over the sine of gamma, what would you set it equal to? Well, you might try a over the sine of alpha, but see, there's a problem. Because I don't know c, but I also don't know what? I don't know angle alpha, so I couldn't figure that out. That's two unknowns. The law of sines only helps you if you have both an angle and its opposite side. So those of you that said, hey, the first step is find c, absolutely. That's your first step. Find c. How do you find c? Okay, c squared equals a squared plus b squared. But you're only saying Pythagorean theorem because that's a right angle. What if it's not a right angle? Well, then you'll need the law of cosines. Law of cosines is almost the same thing. C squared equals a squared plus b squared. What's the only thing I have to subtract? 2ab cosine of the angle across from C. And what's that called? We've been calling it gamma. All right? I'm going to do it this way. Even though you guys are right, you could use Pythagorean theorem. I want to do it this way to show you something. So if I'm going to fill things in, I get c squared equals 3 squared plus 4 squared minus what? 2 times 3 times 4 times the cosine of what? Yeah, the cosine of 90 degrees. Now, what's special about that? Do you guys recall what the cosine of 90 degrees is? Okay, see, that's the deal. The reason that, see that? The reason the Pythagorean theorem works, you could say, is because this equals 0. And if that equals 0, all we really have is c squared equals 9 plus 16. Right? Minus 0. C squared is 25. C is 5. C is 5. So once I know that C is 5, now I'm ready to find alpha or beta. All right? So how would I do it at this point? Now I can use law of sines, right? So let's do it. Let's find alpha. Sine of alpha over 3, what would I do next, is equal to, I need to find one I know. Well, I happen to know the sine of gamma, right? And I know 5 is the side opposite. By the way, what is the sine of gamma? 90 is gamma, so what's the sine of 90 degrees? It's 1, right? So the sine of alpha is 3 times the sine of 90 over 5. But you're right, that's 1. So this is just 3/5. Actually, I should have known that, right? The sine of alpha is 3/5 because of the picture. It's a right angle. So again, this is a very special case. But now, how do I find alpha? Well, I'm going to do the inverse sine of 3/5. How many degrees? Well, it's approximately 36.9 degrees. And I know what gamma is, so I ought to be able to get beta by subtracting from 180. And so I'm going to get 53.1 degrees approximately. Okay, we have all the angles of the triangle and the sides of the triangle. So it turns out exercise 17 on tonight's homework asks me to find the area of some triangles. I thought this was a cool exercise, actually. This triangle here, if I have to find the area, simple, right? What formula would you use? 1/2 base times height, right? So the area is 6, right? You'd pick the base and height that they have to be perpendicular for me to use that formula. And I showed you on last night's homework, in order to find the area, you can actually draw a height and figure it out with law of sines. Okay? But it turns out there's even a more clever way to find area. Okay? And it's in your book in this section on law of cosines. It's called Heron's formula. So Heron's formula is the following. Heron proved this in about 200 AD. He's one of the ancient Greek geometers. And he proved that the area is equal to S times S minus A times S minus B times S minus C. Those aren't 5s, that's an S. And I have to say what I mean by S. S is what's called the semi-perimeter. What's the prefix semi mean? Right, like a semicircle is half a circle. So what I mean is half of the perimeter. Now why half of the perimeter? Well, what's the perimeter of a triangle? If we have a triangle with sides A, B, and C, is going to be half of this A plus B plus C, right? It's a remarkable formula. I mean, almost magical. You know, like I said, problem 4, I have no problem finding that area. But I want to go back to problem 12. We had, in problem 12, we were able to find all the pieces, parts of the triangle. Okay? But now if I said find the area, this is a real convenient way to do it. Because if you think about it, all they told me was A, B, and C. They told me A is 37, B is 45, and they told me C is 26. Okay? So that's actually enough for me to use Heron's formula. I guess the next thing I need to do is compute S. So let's see, in my example, S is going to be 1/2 of, well, the perimeter. So let me work out what that is. Well, let's get that in the calculator, right? So I'm going to go ahead and try this. I'm going to do 37 plus 45 plus 26. Oh, then I have to divide by 2. So 108 is the perimeter of the triangle. So half the perimeter is 54. Okay. So S is 54. And S appears so often in that area formula, you're going to have to keep typing 54. All right? So let's try using this now. We'll use Heron's formula to come up with the area. And let's see. If I want the area, I need the square root of, well, 54 times, and then in parentheses I need 54 minus 37. That's S minus A. Plus, oh wait, I put plus. I need times. That's not going to work. And then I need times. And now I need 54 minus 45. Close parentheses. times, open parentheses, 54 minus 26. And then close parentheses for the square root. And so according to this, the area of the triangle that I found on the last page, the area is around 480, maybe 481, let's say. And they didn't give me dimensions, if there's, square feet, if these are feet, or square inches, if those are inches. But we found the area using this formula. Now, if you think about how hard it would be to find the area, here, without the formula, I just want to kind of show you what we'd have to do. I drew a picture last time, right? And so now, let's see. I had 37, 45, and 26. Right? But the problem is that if you wanted to use your formula for 1/2 base times height, what would you do next? Well, you could use any of these as a base, but what else do you have to draw? You have to draw a height, h, right? And what I know about the height is I have to make it perpendicular. So think about what you'd have to do. How would you determine what that h is? Well, Pythagorean theorem would work except for one problem, right? I don't have, like, this leg. I almost do. I know it's smaller than what? Smaller than 45, right? Do you think it's half of 45, or do you think that doesn't work? No, that doesn't work because these are different length sides. Okay? So it's actually pretty remarkable that they came up with the formula, but that's what's being explored in 17. The proof of why it works is more complicated than what I did for the last section area problems. And it is worked out right in the book, but I'm gonna let it go for now because we only have 5 minutes left. And I want to make sure that I get together a little bit of what's going to be on the test so you guys understand what's coming up. Now let's make a little list of the exam 2 topics for you. This will just be smart to do. Okay, so exam 2 topics. Things we've done since exam 1. So in 10.4, I remember we did the identities with the song. All right, we've done those already. But now I'm going to have what I would call the double angle identities. And also the half angle identities. So things like sine of 2 theta and things like sine of theta over 2. And then also cosine and tangent, right? And you'll find we took 2 quizzes on these. We did quiz 3 and 5 covering 10.4. The double angle and the half angle. Those are the new ones. I'm assuming you already know the sine of alpha plus beta and the cosine of alpha plus beta from the song. That was on the first exam. I assume you know those. Well, otherwise, how are you going to know these? I mean, to me, knowing these is no hard to, because it's just theta plus theta gives me 2 theta. Okay? So I guess that's what I would say. And as far as tangent, why do I not worry so much about tangent? Because how can I always find tangent? Do sine over cosine, right? And I will say, everybody improved on quiz 5 compared to quiz 3. So that was nice to see, which is good because I know I'm going to be dropping a quiz. Quiz 4, what was that on? Well, that was on section 10.6, inverse trig functions. And you will have inverse trig functions on the exam on Monday. And the only other thing from Chapter 10 is 10.7, trig equations. And remember, I decided to grade the most recent homework. We did 2 assignments on them. So quiz 6 is going to be how well you can do trig equations. I guess I'll find out today, right? Start grading that. I'll see how you guys are doing. That'll give me an idea of how much time to spend on this on Wednesday and how much time to spend on other things. Then we got into Chapter 11. 11.1 we skipped. We have 11.2 on the law of sines. And please, for Wednesday, complete the homework on 11.3, the law of cosines. Those are the topics for the exam coming up. All right? All right. Nice work today.